welcome to your first official CS50 section. As you can see, this is section very CS50-like. Just to pull up our agenda for today. So who am I? As I'm sure you're all wondering, I am your TF. I'm not just a random student who's impersonating your TF. And I'm going to go through kind of how section will flow, expectations we have, resources, so on and so forth. We're going to talk about arrays, ASCII, functions, command line arguments, and it's not on here, but I will also be helping you kind of think through your next PSet for this week, which I'm sure you will all appreciate. So, first question, who am I besides your exuberant TF here? I'm Allison Buchholz-Al. This is my second year TFing CS50. I also TF CS51 in the spring. You might see me again there if you decide to take it. I'm also a PAF, so any freshmen, and if you're not a freshman, this is my third year as an advising fellow. I'm very well versed in advising you on life and courses within CS and not within CS. I am a computer science concentrator. I'm a senior in Adams House, best house. And before I switched to CS my sophomore spring, I was actually a biomedical engineer. I was going to go to med school. I was going to be a trauma surgeon. And that has completely all changed since I took CS50. I took the course my sophomore fall. It was my first introduction to CS ever. I was one of the 78% of you who had zero experience coming in, and it completely changed my life. And now I'm working at Microsoft, and your lovely TF and CS50 is probably one of the best experiences that I've had here at Harvard, both taking the class and being able to help teach students like you. So I'm really excited that you're all here. In case you came in late, there is candy, which you should feel free to come grab or send someone else to grab it for you. It's okay. I don't want to eat that. My room has enough chocolate, so y'all should try and finish that. I know there are 100 pieces, but like, it's 4 o'clock on a Monday. I think everyone could use some sugar. So all of you who are officially in my section should have gotten an email from me with my phone number, email address. Feel free to add me on GChat. Feel free to add me on Facebook. And also, for the rest of you, you can email me right here. There are 2 H's. Everyone always does like 2 L's or 2 C's, 2 H's in the last name. Otherwise, it's going to bounce, and I'm not going to get your email. So feel free to email me, contact me at any time. I may not get back to you within 24 minutes, but I promise to get back to you within 24 hours. If you call me half an hour before your PSet is due, being like, I have no idea what I'm doing, Allison, help me, I'm going to calm you down. But you know, at the end of the day, if you're calling me half an hour before your PSet's due with nothing written, I'm going to be like, well, maybe it's time to use that late day. So I will respond to all of your requests in a very timely manner. My phone is usually attached to my hand, so I typically respond much quicker than 24 hours, but I can only guarantee a 24-hour response. All right, so why are we here? Also, if you have questions at any time, please let me know. I talk a lot, I talk fast, but please feel free to interrupt me. It gives me breathing room as well. So sections are a time for us to really just dive in, get some hands-on experience, to go through topics that we mentioned in class or in study materials that we recommend to you guys online. And we'll actually go through some of those resources in a bit. So, some notes on section support. CS50, one of the things that makes it one of my favorite classes is the feeling that you're never alone. We have a staff of over 100 people who are here to help you. We have office hours Mondays through Thursdays. So there are so many people who love the class just as much as I do and who are really here because they want to be here. Most of us are students, and this is like a 5th class in addition to the rest of our work. And it's a lot of work, but we do it because we love it, and we really love to teach you and help share our excitement for this subject in this class. So please take advantage, come talk to us. I get lonely when my students don't talk to me, so if you want, come hang out with me. It'll be great. So section is obviously one of your biggest things. We'll go through things that you learned in lecture, do some short examples when we have time, and generally kind of get an idea about things you should be thinking about for your problem set. Shorts. Some of you, how many people actually watched the video from your Scratch short? Anyone recognize me? So those are very great. You should definitely watch those. A lot of work has been put into them, and they are just meant to be bite-sized pieces for you to just kind of, watch for 3 or 4 minutes and get a better understanding of a concept. walkthroughs. How many people have watched the walkthroughs for previous ones? Zamila's amazing, right? Like, I wish I was Zamila sometimes. So definitely use your walkthroughs. She will break it down into small bite-sized pieces. And when you have these huge specifications from your problem sets, it's going to be really important to be able to just find somewhere to start and work slowly through it. All right, we also have Study 50, which is study50.harvard.edu, I believe. If you just Google Study 50, it'll come up. This is your one of the best resources we have. It is PowerPoints with notes and practice problems for you with solutions that you can actually walk through. So if you ever want more practice, more than we do in section or more than your problem sets, this is really a place I encourage you to go. It was built last summer by some of my really good friends, and it's amazing. In fact, a lot of the slides that I'll be using for section will come from Study 50. So a lot of the TFs use it. And finally, as I mentioned, office hours. If you're having trouble with homework, if you're having trouble with a concept, come to office hours. Go early in the week if you can. Get out to the quad because it is kind of far and no one likes to walk out there. But it's to your advantage because then you're going to have all these TFs who are just around you. And especially now, just a tip, Thursdays are very chill right now in Mather because your PSets are due on Thursdays and no one wants to use their late days yet. So if you're having trouble with concepts, there are lots of TFs who are there to help you. So come out to Mather on Thursday. If you want to see me, I'm going to be there. I'm typically doing my own homework because no one wants my help. So come see us. Meet us halfway. So how many people have attended lecture or watched it online? How many people went to super section last week? Okay, cool. That's actually like a fair number. How many of you have read your spec for this week for your PSet? Ooh, I am proud of you guys. More candy for y'all. Good. So when we mean meet us halfway is that section is really only going to be super useful to you if you come in having read your specification for your PSet. Because when I go through an overview of things you should be looking out for, it's not going to make as much sense if you don't know what your problem set is going to be asking you to do. If you don't come to section, obviously I can't be that useful to you. I'm not going to take it personally if you don't come to my section right now, but definitely you should. If you can't, watch them online. They're there for a reason. Mine will be right there. As you notice, we're being recorded, so it'll be right there for you guys. As well, going to lectures, that's obviously where you're getting the start of your material here. So I will definitely try and help you as much as I can, but I can only meet you so far. You have to kind of meet us halfway there. Grading. So all of you who got an email from me, you were my official section. I will be grading your PSets, and I just want to say one thing that you should really pay attention to are the comments. The comments are often more useful than the actual score we give you, and the comments are actually where I spend a lot of my time when I'm grading. So I would appreciate it if you read them, and they're actually how you're going to learn more about design and style and things that are a little less cut and dry. So really pay attention to those comments. If you have questions about them or questions about your score, please come talk to me either before section, I'll probably be hanging out in the lobby, or afterwards. If you want to schedule one-on-one meetings about how you can help improve later problem sets, just let me know. And then just a couple of tips for you guys. So one of the biggest things I always stress to my section when you're learning how to code is to write things out on paper first. If you have a game plan for where your code needs to go and what it needs to do, and it's broken down into little bits of pseudocode that you've written out, you're going to be less likely to make syntax errors or create an if loop that doesn't have an else. It'll just give you, if you know where you're going overall, you're less likely to make these tiny mistakes that will sometimes take you hours to fix because you're where am I missing this bracket? On that note, style. Please use style 50, especially when you're going to office hours. If your code is just all smushed over to one side, it is course policy that we can say, fix it so that it looks like style 50 says it should, and then we'll help you. So it'll make your lives easier, it'll make our lives easier, everyone's happier, everyone gets better grades, and isn't that what we all want? So write things out on paper before you ever touch your computer. Talk things out at a high level, make sure you know where you're going. And if you're unsure, sit down with someone and kind of walk them through step by step what your code is supposed to do. And 9 times out of 10, you'll be oh, I forgot an if condition, or I forgot a semicolon here, or I'm updating this variable wrong. So those are my tips for success. So since about half of you look like you attended super section, I'm just going to very briefly go through loops, which weren't on our original agenda, but they are really important, and so I'm going to kind of speed through those before we get into our actual section. Before I do that, are there any questions, logistically, personally, if there's anything else you want to know about me or about section or class in general? All good? Okay, cool. Lovely. So loops. You guys should all recognize these pieces from scratch. So loops are basically just a way for us to do something some number of times, some repeated action based on some conditional. So we have three different types. We have for loop, while, and do while. So for loops, we just have a very general kind of layout here of a for loop. And this is great for when you know how many times something needs to execute. When we talk about the other loops, you'll see why that's like an important distinction. But for loops are for something set. You know you can either calculate the number or you know the number of times you want this repeated at the beginning. So if we see here, we have just the general kind of skeleton framework for a for loop here. So for initialization, this is where your variables are initialized. With Mario, I'm sure you guys did something like int I equals 0. That's where that would happen in blue. You have your condition, which is what's checked every time. If this condition is true, then the rest of the code executes. Then it'll run again and ask. And then we have update, where you're updating your variable. So again, with like Mario, I'm sure you guys did something like I++. So every time the loop ran, I got updated so that when we were checking it against some condition, it was changing. Because if you just kind of have a static variable, if it executes the first time, it's just going to execute infinitely. So you have to make sure and update your variable properly. And then we also kind of have just a visual representation there. Everyone good? For loops. Should have seen these in your PSet. Cool. So here's just an easy example. Prints this is CS50 10 times. And so we have our initialization, as we see there, with int I equals 0, for I is less than 10, and I++. Cool. And it'll print that 10 times. So while loops. While loops are great when you just, you don't necessarily, if you notice there's not necessarily, you don't necessarily have to know how many times it's going to update in the beginning. You just have some condition that's checked. And this could be something like while, an example from your PSet, if Mario, you tried to input a negative number, right? You were supposed to reprompt your user. So you can say, while, user inputs, something less than 0, reprompt them. And I'm sure that might have been something that some of you used in your code. So simple thing, you have while, some conditional, that is checked every time the code goes to execute. It evaluates to true, we run it, otherwise we don't. And what's really important, something I think that David talked about in lecture, are the braces. It's only within, whatever's within the braces is what's executed. If you forget those braces, it's only going to be the line directly after the while that's executed. So if you have 3 things that are supposed to happen when this condition evaluates to true and you don't have those braces, only the first thing is going to happen. So be very cognizant of where you put your braces. If you stick with style 50, this will definitely help you. Cool. So this one just count down. This is a countdown from 10 to 0. And as we see here, we initialize some counter outside of it. One thing that's different is we're not initializing our variable within our while loop. It's initialized outside of it. We are simply just putting the condition in for our while. So in this case, it's while count is greater than 0. And we print out what our count is, and then we decrement our variable. And that's also another thing to notice. Our update doesn't happen within that first part of the while loop. It will actually happen within the braces, the body of your text. Cool. So do while loops. Do while loops are great for user validation. So some of you might have also used this in your PSet. You can say do, like ask the user for input, and then while like the input is less than some number. So for an explicit case with Mario, it would be do printf enter an integer and then some integer equals get int, and then it'll actually execute that code first. So you'll actually have some sort of integer, and then you can say while that integer is less than 0. So what it's going to do is it's going to execute at least once. It's going to check the condition. If the condition is true, it'll run again. So do-while loops are great for user validation because you can actually, that the code is going to execute at least once. Whereas with while loops, you're not guaranteed that it's going to execute once. It's going to check the condition first and then decide to execute it. While a do-while will execute the code first and then check to see whether if you need to repeat it. Does that distinction make sense to everyone? Okay. Cool. So in this case, this is kind of what I was talking about. This reprompts until you get a positive number. So we know that printf enter a positive number and actually asking for that input will happen at least once. If the user is evil and keeps entering a negative number, who knows how many times it'll execute. But this code is guaranteed to execute at least once. And that's why it's great for validating input. And you will use that quite a bit. All right. Any questions so far? We're all good? Am I talking too fast or we're good? Okay. Awesome. So we're going to go ahead and talk about arrays. Cool. So arrays are basically just data structures that allow us to store things of the same type. So if you ever have an array, it's either just going to have ints, or it's just going to have floats, or it's just going to have chars. You're not going to have an int with a char, with a float, with a double, one thing. Arrays are just one size, or they're just one type. So here we have an array of size 3 with 3 integers in it. They could be floats, but we're going to say they're ints. So it's one thing to realize is that arrays are a set size when you initialize them, and they are not easily, since y'all are less comfortable, you should just think of them as not being able to extend in size. However big you set out your array in the beginning, that's the size it's going to stay, because arrays are continuous blocks of memory. And when you guys get into a little bit more of how memory is actually laid out on disks and in the heap and the stack, it'll make a little more sense. But you could just think of it's just a row of spaces on your disk, and you can't guarantee that there's going to be free space after it. You could initialize an array of 3, and then maybe you initialize another array of 5 later, and it's right after that. So if you were to go past spot 3 in that first array, you would be writing over something else. So arrays are, for you guys, just think of them as a fixed size. So creating an array. You're going to need to do this quite a bit. So in the same way that we have just a general structure for our for loops, we have a nice general structure for our array. Because they're of one type, all of the elements in an array are one type, you need to initialize what that type is. So if you see here, we have the nice little bracket data type. So if we're creating an int array, that will be int. If we're creating a char array, it'll be char. If we're creating a string array, it'll be string. And then the name of your array, whatever you'd like it to be. So maybe it's test scores, or maybe it's students, or maybe it's candy. Whatever you decide to name your array, that's what it'll be. And then in brackets, you'll have the size that you want. So are we storing 10 students, or are we storing 15 types of candy, whatnot. So in our example here, we're creating an array of size 3, which you guys see right here on the right. And when we want to when we first initialize it, everything is set to 0. So it's just kind of thought of as a blank slate. We have all these spaces, we have all these boxes we can put our data into, but they're just blank for the time being. So if we want to actually assign them these values, we do so as right under here shows. So you have whatever the name of your array is, and then what index you want. So the index just refers to what slot we're looking at. And an important thing to notice is that arrays are 0 indexed. So if we want the first space in memory of our array, it's going to be 0. We want the second, it'll be 1. We want the third, it'll be 2, so on and so forth. Which is also why conventionally when we do for loops, I'm sure you guys were wondering, why do we start at 0 versus 1? And that's because when we transition into using arrays, it maps correctly. So if you want to iterate through an array, it makes a lot more sense to do I equals 0 because we know that will correspond to the first spot in memory. Everyone good with that? So cool. And then on the bottom here is just another way to initialize an array. You still have your data type, the name, but instead of actually putting a size in there, you can just do empty brackets. And then with these curly braces at the bottom, you can just input the data that you want separated by commas. And that will automatically say, OK, I see that you have 3 things in these braces. So I know that I need to allocate 3 blocks of memory and then store those. Mm-hmm. So the first version you might use if you're asking your user to input values so that you can iterate through the array and ask, get some in to input them. If you know the values beforehand, it makes a lot more sense to use the second way. But in most cases, you might not know what those values are going to be. Cool. Any other questions? All right. So accessing elements. So one of the great things about arrays is that they are random access, meaning that you don't have to look through every block. If you know that you want what's in block 2, you can just say, give me block 2. And that's why these indices are so important, and that's how we actually access them. So in this case, as we saw before when we were assigning values, the one before, we had the name and then the index we wanted to access, right? So in the same way, that's all we do to actually pull that data out. We have the name and we have the index that we want. So in this case, the for loop down here at the bottom, anyone know what it's doing? What it would print out? Mm-hmm. Exactly. So yeah, it's just iterating through. So I is equal to 0. We can walk through the code just quickly. I is equal to 0. I is less than 3 at this point, right? So that checks out. And we say, OK, printf whatever is in temperature I. I is 0 right here when we first iterate. So we go to this first spot, and we say, OK, 65 is the number we want to print out. So it'll print out 65, and then it'll do a new line. I will update. So it prints 87. Updates again, and it'll print 30. Everyone cool? Awesome. All right, so here's kind of one thing I was saying, how you can kind of keep track of someone's score, why you would use the first way of initializing it instead of that second way. And this just goes through, and notice we have a class size of 30. And we're initializing this array of ints that is of size 30. And then we are iterating through, and we're asking the user to input scores for each of these, and then assigning it to a specific place in memory somewhere in that array. Cool? Does that make sense to everyone? Mm-hmm? I guess I haven't seen the hashtag define class size 30. Mm-hmm. Yeah, so hashtag define class size 30 it's a preprocessor directive, which just means it has to do with like the compiling process. You can think of it as a global variable. The way we do it is typically it allows your code to be more easily changed. So let's say that our class size suddenly goes from 30 to 15. If I hadn't defined it this way, I would have to go through my entire program and change every instance of 30 to 15. But with this, I get to change one spot, and everything else changes. If you ever want to do a hash define in a case where you're keeping track of some set number of scores for a class, or you're using a number that will be used like throughout a very long program, it's better to define that at the beginning so that if ever it changes, you get to change one spot instead of like 100. Yes?
What's the difference between doing that and then just declaring a variable right at the top?
So it has to do with like efficient. It's kind of like outside the scope of what we can cover in this section. It has to do more with efficiency and how things actually work in the compiling process. That you don't really need to worry. If you want to really know about it, I'm happy to like send you an email with like resources about it. Hash define tends to be preferred for things. And as you code more, you kind of learn the nuances of when you should use a global versus a hash define. But for the time being, you don't really have to worry about it, is the short answer. Everyone good with that? And also, if you want to use a hash define, really important to notice that the name should be in all caps. We're not just doing class size to be dramatic. It should actually all be in all caps. Cool. Anything else there? We're good? Lovely. Welcome. OK, so I want you guys to take a look at this and see if you can find the bug. I'll give you a hint. It's somewhere in the for loop.
Should be less than or equal to 2.
So it could be less than or equal to 2, or it could be less than 3. And what's the reasoning for that?
It starts from 0, 0, 1, 2.
Exactly. So exactly. In an array of size n, we only have indices of n minus 1. Cool. Then we can get really crazy and get multidimensional arrays. One of the problem sets when I took it my year required multidimensional arrays, and I think one of them might require it this year. So be comfortable, wrap your head around it now. It will come back to haunt you, but in a cool way. So you can really just think of multidimensional arrays as arrays of arrays. So you can kind of think of like this top row is like the first chunk of memory, and then this one is the second chunk of memory, and the last row is the third chunk of memory. And then within that, there's an array. But of course, it's easier to depict like this. So you initialize it the same way. So this is a character board of 3 by 3. So you have 3 rows and 3 columns. We're representing it this way. And you would access it the same way, column by row. And so 1, 1, as we see here, we assigned an O, 0, 0 up there, 2, 0, and 0, 2. So you would just access them. If anyone's ever done like linear algebra, the same way you access an element in a matrix, the same idea here. So you can relate it back to math. Don't have to worry too much about this right now. Good to have exposure to. Know that you can do it. You can create some crazy number of. You can create crazy arrays. Is all I'm gonna say. Done before. Gets a little crazy, but it's really cool. Awesome. And then so we just have an example here. It calculates string length. So how many people knew that the strings that you're using are just arrays of characters? See that? OK. Yeah. So you guys may think that you haven't used arrays before, but anytime you use getString in the CSFG library, you're actually just asking for an array of characters. And we're taking care of all of that in the back end for you, but you have been using arrays since you started. You just didn't know it yet. And whenever you have a character array, or an array that's storing a string, the last thing is always what's called a null terminator, which is this right here. And that is at the end of every word that you're storing. So if we want to figure out the length of a string, we can say, while the contents of that block is not equal to our null terminator, that means that there's some character there that we actually care about, that's part of the word, you increase your length. And then when we actually get to the end of the word, it'll terminate, and it'll return our length for us.
If there's multiple words, does a space count as the null terminator?
So a space is not a null terminator. So if you have multiple words, a space is actually like a specific ASCII value.
Okay.
Yeah.
What's the exclamation equal again?
So this is what we refer to, if you ever hear me in office hours, I always call it like bang equals. So bang is not. So this is not equals. So if you ever want to do like, if you're trying to see if something's false, you can always do like bang, whatever the variable is. And if it's false, it evaluates to true, and you can do cool stuff with that. More on that later. Cool. Everything good there? Awesome. So now it's your guys' time to work, since I've been talking. So I want you to just create an array with the integers 1, 2, and 3, and then have them printed out. You don't have to do like main, blah, 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 whatever. I just want you to initialize the array and then create a for loop to print them out, or a while loop, up to you. But I'll just give you a couple minutes to work on that. I'm going to rest my voice, if you have any questions, I'm happy to come around and talk with you guys. Feel free to talk with each other. Get more candy. In fact, I'll just walk around with candy. How's that? Johnny? Oh, no worries. You guys are killing it. Anyone else in this row want candy? Yeah, you can also take more than one, guys. Take a handful if you want. May as well. Everyone else good? Okay. Yeah, also if I can, you know what, I'm going to create like an anonymous Google form and you guys can just submit feedback after every section if there's something you want me to improve upon or something you want done. I'm a little too peppy for you. I can tone it down. I'll create that and send that out to you all afterwards. All right, so let's start small. How would we initialize our array? Okay, what's the type of our array? An int, right? Okay, so what do you want to call your array? Int array, cool. All right, so we have int array equals, and what do we have after that? The braces, and then inside the braces, 1, 2, 3. Cool. So that's our array. So now we have our for loop. So first part of our for loop, what do we have? So int I equals 0. And then what is our condition? What's I going to be less than? Less than 3. And how do we update I? I++, updating it by 1. And then we're going to have some printf of the integer and what is that last part that's actually going to say what we should be printing. Be the name of the array, which is int array, right? And what's in the brackets of int array? I. So I called mine example, but there you go. Not that bad. Everyone good? Cool. So we're done with arrays. Congrats. You've managed to iterate through all the... Yes. Yes.
I have a question. Are you supposed to indent the braces and everything?
So the braces should line up with the for loop, and then everything inside the braces should be indented.
Okay. Should the for loop be indented?
The for loop does not need to be indented at this point. If you were in main, if we actually had like a main function here, it would be indented from main. But in this case, it's fine. Yes, question?
Do we need to have the brackets after example?
If you're initializing it that way. So remember, this is the second way of initializing an array. where we have the braces and then our actual data separated by commas within.
I thought there were brackets for that example.
No, they're braces. They're braces. If you're initializing it the second way, it's braces. If we were to say int example, if we just wanted a blank array for ints, it would be int example brackets 3. The brackets represent the size. When you have braces, it's the actual data you're putting into it in this way. You can scroll back really fast. So in this one, this is just our initial array, initialization. And here we are individually assigning spots to them. So this represents the index of our array, which is why we have brackets. But here, if you notice, we've left our brackets without a size, and we initialize it with the actual data all in one with braces.
So why don't we have brackets in this example?
So in which part?
Like wouldn't we say int example brackets equals braces?
Yeah, you're forgetting the 2 brackets. Like,
Oh, sorry.
example.
You're right.
Okay.
We do have brackets there. Sorry, guys. My bad. Yes, you should have brackets after example.
Okay.
You're
Or
absolutely
could you get
right.
away with not doing it?
No, you have to have brackets because otherwise it's not going to declare an array.
And brackets around what there?
Sorry, you need brackets after example. Typo.
Oh, okay.
Good catch. Gold star for you. Also, if you are asking a question, if you guys would just tell me your names, I'd love that. I'd love to be able to know all your names. I'm not going to cold call you. I actually do just want to know your names. So please actually tell me your names. Leah. Okay, so functions. I know they talked about this during lecture. So functions are kind of just like these little bite-sized things where you pass in inputs, something magical happens, and you get outputs. Cool, so you've actually used a lot of these already. Get int, string, printf. These are all functions where you just call them. There's lots of magical things going on in the background that you don't necessarily see, and then you get out what you want, or at least you get what you hope you want. And basically the point of functions, and one of the main themes of CS, is to break your code into manageable pieces. When you start writing these like really long programs or in Scratch, when you had this grand idea for a game, you need to be able to break it down to like, okay, how do I start? What are the little pieces that I need? Oh, I need to ask the user for something. Now I need to print something. Oh, I need to calculate this value. And learning how to break up your code and the large problems you have into these small pieces and creating functions is actually one of the big cornerstones of CS. So yes, you can think of a function just as like a black box, a magical black box that you put things into and you get some output. And the rest of the program doesn't need to necessarily know what's going on within that black box. All it cares about is what goes in and what comes out. Cool, so why functions? Organization. As I said, like when you're dealing with very large code bases, how you organize your code will be much easier if you use functions, because you'll be able to be like, okay, this is what this function does, and here's what another one does, and you can easily see how they all fit together. So breaking it up into all these manageable subparts. So simplification. I'm sure you guys all saw this, as I said, with Scratch. You have this grand idea, and you're like, how does all this work? But if you approach it, piecemeal, and you say, okay, how do I make one sprite, float across the screen? That's a little bit easier. So good use of function makes your code much easier to read. It makes it easier to debug, which as you get into your later problem sets, you're going to really want to be able to do. And they're also easier to design and implement. You can, code up a small function relatively quickly and make sure it works versus trying to create this whole long program and then kind of go through and see what's working and what's not. And then reusability. So functions only need to be used written once, and then you can use them as many times as possible. So it's like eco-friendly in a sense. If you had things like printf, where you had to write out, the magic that goes on behind printf every single time you wanted to print something, you would be pretty sick and tired of it by the end. One of the things that you'll learn in later CS classes, or one of the best pieces of advice I get, is if you are copying and pasting code, it should probably be a function. If you have the exact same lines all throughout your code, If you factor them out, your code would probably be like 5 times shorter and be much more easier to read. And instead of trying to troubleshoot all these different places where things might go wrong, you have one function that you get to troubleshoot. And I promise a lot of this might seem kind of abstract now, but as you get into later and later problem sets, it will make a lot more sense and really be driven home. Are there any questions about functions so far? Why are we using them? I know we haven't gotten into the nitty-gritty yet. So defining a function. Just like arrays, we need some sort of, this is just the general output. So this is a function that's just going to cube some input. And on the next page, actually, we have all these awesome little things here. So can everyone read that out of curiosity? I know it's the purple and black, might be a little hard, but big things to know. So the first one right here is our return type. So this is talking about the output of this function. When, in this case, when we put in some number, what we're getting is that number cubed. So it should be an int in this case. Maybe it would be a double or something else later. But in this case, it's an int. With C, you always need a return type. It'll be an int, it'll be a float, it'll be a double, but you have to specify what this function is going to return. Otherwise, it will yell at you, and it won't compile. You'll be sad, and I'll be sad, and it's just not good. OK, and then we have our function name. As you can see here with C, there's this very consistent paradigm. What's your type? What's the name? And then some other thing at the end. So we have our return type, our function name, and then we have our header or with our parameter list. So the parameter list is what is this function going to take in? Parameter list is simply a synonym for what are our inputs. And in the same way that we have to define our function and give it a return type, each of our inputs needs to have a type associated with it, so we know what our function can actually work with. So in this case, we have some int input. So again, it'll be the type and what you're calling it. And then, as you see here, we have our body. So we have some int output that is just our input times itself, which just cubes it. And then we return that output. So as you see here, we have an int times an int times an int. So it returns an int, which has been declared there. So everything is cohesive. Everything's happy. Your function will run. And this is just a general thing. So always have return type, name, your parameter list. Each thing in your parameter list or input needs to have a type associated with it. And then you have your body here with whatever you want to do with your input. And then obviously you want to return something. Sometimes functions will just return. They don't actually return like something for you to use, but you have to return in some way. And when you're making your own functions, we can get into that a little deeper, like personally if you want. But there are a lot of different things you can do there. Everyone good? Anything on this list that you want me to go over, you didn't understand? Everyone's good there? Cool. Awesome. OK, so we're putting all this together now. So we have some int cube inputs. So this is like this is a complete program here. Up until now, I've kind of been giving you guys snippets that might be going within a program. We've just been looking at functions, but here's an entire program. So how many of you remember the word prototype from lecture? Cool. We got one lucky star there. What's your name?
Steph.
Steph? OK, awesome. So do you remember what a prototype is?
Like you say the function or whatever it is like before you actually deal with it.
Do you remember why? OK, gold star. So yes, a prototype we have beforehand because otherwise our compiler is going to yell at us. It's going to say, OK, what is this cube function? Like you literally have told me nothing about this. It's like when you walk into a classroom and someone's like, there's a quiz today, and you're like, you never told me about this. I'm not happy with this. The prototype is basically like your syllabus saying like, look, heads up, there's going to be a quiz on this day. Don't freak out when you get to it. You're going to be fine. So all the prototype does is tell main, I'm going to use this function. I promise I'm defining it later. Like, don't freak out at me. Just compile and do what I tell you to. So we have the prototype there just to make our compiler happy. And it's basically a promise that you have defined this function later, and that you aren't just calling this random thing that it doesn't know what you're going to be doing. So in this case, we have main here. We initialize some integer x, that is 2. We're going to print out what x is. We're going to cube x. And as you see, we have our function declaration down here that we talked about previously. It'll cube x, and then if we remember, the cube function actually returns an integer to us, which is stored in x again, so that we can print out 8 for cube x right now. Does that make sense to everyone? Good? All right, awesome. All right, how many of you guys remember this? Okay, so this is basically just your stack and your heap. It's just a visualization of how memory is stored here. So we just want to make sure that you understand like how these are represented in memory. If you take classes like CS61 and stuff later, you get to learn this like far more in depth. And it's really cool, and I highly recommend it. But for now, we'll give you the broad overview, so you don't have to know the nitty-gritty. So at the top is just a text segment, which contains the actual zeros and ones, the binary for that. And this is used for storing global variables if you have any. As you move down, we have, as we see here, initialized data, uninitialized data, and then heap. So we don't really talk about the heap right now. We'll get to it later. For now, I'm just going to wave my hands and be like, you don't need to know about this now. But we will talk a little bit about the stack. So the stack is where we have a zoom in. This is actually how the program we just looked at occurs in memory. So what happens is every time we call a function, we get what's called a stack frame, which is one of these. So main's parameters. So those are the things that we pass into main. So they're right here at the bottom, because that's the first thing we call. Then we get to main's locals. And when we say that, we mean the local variables that are stored within main. So we have, go back. So locals here would be like x is equal to 2 in this case, because that's localized to main. Does everyone remember like scope, going over that in lecture? Okay, so just the variables that are initialized within main. So that's why we have main's locals. And then within main, we call cube, right? So we get another frame with cube, so with cube's parameters. So in this case, cube's parameters are now the x that we passed in, the 2 that we passed in. And then cube's locals, which is where the actual cubing happens, and then it returns. So what happens is, as cube actually does what it's supposed to do, it returns. When it returns, this frame leaves, and it's returned down to main. And then within main, we can actually print it. So when you're returning something, when your function returns, it's like passing on those values to the frame below it and then kind of leaving. Things have to execute in order. And when you get into bigger programs, we can make cooler and more complicated diagrams. But for now, this is just a general overview so that you have kind of an understanding of what happens when you're calling a function and how that actually looks in memory. Cool? Everyone good? Awesome. So this is one that is, I feel like this, okay. So this is just trying to swap things. As we see here, we have our function prototype so that our compiler doesn't yell at us. We have some main, and we want to switch x and y. They haven't done this demo in lecture yet, have they? They haven't. Okay. So we're going to go over this very briefly. You'll get into this example more in depth, I think, this week. And then next week, we can like really dive into why this doesn't work. So we have this void function here, swap. So void just means that nothing is returned. And we have swap int a and int b. And we have some temporary variable, that's a. A gets assigned to b, and then b gets assigned to the temp, so that a and b's values are now switched. But, plot twist, this doesn't work. And part of it actually has to do with the fact that a and b here, the ones that get passed in here, are actually copies of x and y. So when the function actually returns, it switches the copies, but not the actual x and y's. So one way to think about it is that pretend these are swap, okay? So in main, we have x and y initialized. But when we actually go up to these frames with swap, we're passing the values over to it, and they're initialized, and they only ever live right here. So A and B live here, and they get swapped. But when we return, we don't do anything with A and B. A and B leave with our function. And so X and Y stay the same. You'll get more into like how to fix that and how we actually deal with that later. But it's just one thing to kind of keep in mind, teaser for the future. Don't worry if that didn't make all the sense in the world. Their copies is the biggest thing. If you're going to take anything away from that, you passed in copies. So the originals stay the same. Everyone good? Cool. So command line arguments. I'm sure in the beginning you guys all had those great like int main voids. And you're like, okay, cool. I don't really care. This is just what I have to write. But in your new programs, especially in this PSet, and why is there chalk on the ground? With your next PSet, you're going to be seeing this. Int main, int argc, string argv, brackets. So from what we just learned today, what do we think that second parameter, or that second element is here? It's an array. What type of array? A string array. Yes, cool. So that's how you're going to be declaring these now. Does anyone remember what these stand for? No? So argc keeps a counter. It's an int. It's a number, right? So what do we think that number is of? Yeah, so argc is the number of strings that make up the command line. So if we were to do, actually, there's a test after, or not a test, but there are examples after this, so I won't get ahead of myself. It's a number of strings that just make up your command line. So when you do like / Mario, that's one string that makes it up. In this PSet, you'll actually be feeding things into the command line, as I'm sure you guys who have read the spec saw. So in those cases, maybe you'll have 2 or 3 arguments. It's going to be a useful thing to use. And then argv, as we said, is just a string array. So that actually stores what you input into the command line. So we have these. We have some /copy in file out file. So if argc is the number of strings that we're passing into the command line, what is our argc in this case? Three. Exactly. So what's arg v of 0? So what's the first thing we've stored? /copy. Exactly. And then the second would be in file. Third would be out file. So what about argv3? It would be null because it's the end of our array, right? Cool. And then what about the 6th one? Kind of a trick question-ish. Do we know what it is? It's undefined. We have no idea what that could be. It's whatever is right after the array in memory, and we have no clue what that is. And it's dangerous to touch those things because for all you know, it's some part of memory that you shouldn't be accessing or null, and it can do crazy things. So it's called over-indexing your array. Don't go outside the bounds of your array, or bad things can happen. Come back, and like the laws of physics have been destroyed or something. Cool. Does that make sense to everyone? Not too bad. So now, everyone's favorite part, PSet review. Yay! Okay, so for those of you who haven't read the PSet spec, you are doing some really cool stuff with cryptography. You're going to create a Caesar cipher and a Vigenère cipher. You should definitely read the spec to see how those work. And if you're having any trouble about like what it should actually be doing, please come talk to me, email me, text me. I'm around. So there are 3 main things here that we want to talk about. Just kind of an extension of lecture, things that you might not know about, hopeful hints and tools. So we're going to do a quick review of ASCII because that's going to be super important for Visioneers cipher. We're going to do conversion of command line inputs, which will be very helpful for Caesar cipher, and then modulo. Cool. So ASCII maps characters to numbers. This is a great chart. You should have this bookmarked somewhere. You will want it for your first midterm. I'm pretty sure everyone has this chart on their midterm sheet. So learn it, love it, keep it handy. It'll be useful. And all it is an encoding that maps alphabetic, numeric, and other characters to numbers for our computer. Because, of course, in the end, everything we store is going to get converted down to zeros and ones. So we need some way to represent the text and characters that we're all used to seeing as some sort of number. So as we see here, we have uppercase A, which is right there, is 65, and lowercase a is 97. So you can figure out, as I said earlier, if you had an array of multiple strings, would each of them have a null terminator? It would be a space. Space has its own special, I forget where it is here. 32 is a space. So everything maps to it. So we have ASCII Math. Pro tip, in Visioneers, you might be tempted to convert your numbers to integers, but it's actually better practice to be able to use the characters like this when you're actually manipulating them. So if you want to use numbers, you can, but a better way and a way that we tend to like you guys to do it is this way, where you're actually subtracting characters. So I want you guys to kind of figure these out. Why don't you try like every other one? So like do the first one, the third one, and the fifth one, because I want to make sure that we talk about everything we need to talk about. And I'm just going to say one of the important things to, oh wait, you guys haven't seen this one. Okay, so do the first three. Let's do that, because we've talked about modulo. I know, math is hard. You can use a calculator. It's okay. Or pull up an ASCII table, because you're probably going to want that. So I will quickly walk you guys through these. So people have ASCII tables pulled up. What is our numeric number for lowercase a?
57.
What was it? It was, so lowercase a is 97, and uppercase a is 65. So 97 minus 65.
27.
30. 62. 62. Yeah. So in this case, what would it print out? That first one. If we have a %d, what would that indicate?
A number.
We're printing out an actual number. So we're actually going to print out 32 here. And if this were %c, 32 would give us a space. So understanding that characters can be printed both as numbers and as the actual characters is really important, and paying attention to the actual types that we're doing here. Cool. So for every other one of these, what are we going to be printing?
Character.
A character. Cool. So if you guys want to know, you can work these out on your own. If you run into trouble, email me. But the second one will print out a lowercase v. The third one will print out an uppercase v. The fourth one will print out a uppercase c. And the last one will be a lowercase a. And the last one, we're actually going to get into what that crazy % sign even means in a couple slides. So try those on your own. If you have trouble, please come talk to me. If you're typically in like Adams D. Hall, you'll probably find me around. So A to I, how many of you have seen this function or heard of it at all? Anyone? Cool. So what it actually stands for is like ASCII to integer. So what you can do is with Caesar, for those of you who've read the spec, you're going to do /Caesar after you write your program, and then you're going to input some number that you want to encode your secret message with. But if we remember, all of our inputs are stored as strings, right? We have an argv array that is all of type string. So if you just tried to pull that 1, it would think that that 1 or whatever number you used is actually a character. So you're going to get some crazy results. So if you actually want to turn this into an integer that you can use to manipulate your word or your message, you want to use a to I. So a to I just converts your string to an int. So if we have, a string of 12, if we call a to I on 12, or whatever that input is, it will actually return to you the integer, not, the character or the string 12, which when you start to add that to numbers will be very different because the string 12 is some crazy number in ASCII, but the integer 12 is actually 12, which is what you want. So you want to make sure, use a to I. You're going to want this in Caesar because you need the int supplied by the user in the command line. But when they put it in the command line, it's stored as a string to begin with. Does that make sense? You don't necessarily need this for Visioneer. Visioneer, as I said before, you should try and use ASCII Math. That looks more like this, where you're actually using the chars that were given to you. Cool. Everyone good there? Awesome. So, modulo. So, what if you're given this huge number for Caesar? You have this idea that if you're at z and you're given a number 2, that means you need z becomes the second letter after itself, right? So you need to somehow wrap around, and modulo is the way to do that. So all it does is it gives you the remainder of the division of the first number by the second. And we have some examples to make that a little more concrete. But basically, you use modulo when you want to make something wrap around. So if you only want the numbers 1 through 8, you can use modulo on any other number, and it will always return a number, from 0 to 8. So some examples. If we have 55 modulo 10, it just gives you the remainder of 55 divided by 10, which would be 5. And then 3 divided by 5, or modulo 5. Anyone guess what that would be? 3. So if you have a smaller number before the modulo, it will always be, it can't go in evenly. It's 0, so then it just returns the number itself. So 8 modulo 8 would be 0, because it goes in evenly. 16 modulo 15? 1. Cool. And then this last one is just to show you, you might be wondering, okay, what's the order of operations here? Do we divide first? Do we modulo first? So modulo holds the same precedence as division or multiplication, and it's left associative. So it's in the same way. You would always do parentheses, then multiplication, division, and modulo in order from left to right. So standard rules, just put it in the same category as division and multiplication. So in this case, we would have 1 plus 2 gives us 3. We multiply that by 2, so we get 6. We modulo that by 2, which gives us 0. And then we add 2. So we get 2 in this last case. So modulo, you're definitely going to be thinking about ways to incorporate that when you're wrapping around the alphabet. If you're at Z and you need to move forward 3 spaces to get to C, there's that whole concept of wrapping around. So I will leave it to you guys to figure out how exactly you're going to be using it. But definitely a useful tool for your PSet this week. I really like this. This is one of my favorite PSets. Then after you do it, if you have friends, you can send each other secret messages and make sure it works because it'll decrypt it or whatever. Lots of fun. And that is the end of section. We still have, I finished early, I still have 15 minutes with you guys. So if there's anything that you would like to go over further, I'd be happy to do that. Any other questions on your PSet for those of you who have started or read the spec? Anything that we've talked about in the last hour and 15 minutes that you'd like me to kind of rehash, I'd be happy to. Or we can call it quits and you can all leave and take more candy with you as you go. But if there are any lingering questions, please let me know. You can also come up and talk to me afterwards. I promise I don't bite. Anything else? Everyone's good? Everyone's feeling like they can handle this PSet? You're gonna be fine, guys. Office hours are there for a reason. Cool. All right, well, in that case, thank you all so much for coming. I hope to see you next week. There will be more candy. There might be other cool things. And I look forward to getting to know all of you this year.